Okay, assalamu alaikum, my brothers and sisters. Let's come back. Our class of today will be reactions of metals with dilute acids, reactions of metal with dilute acids. So generally, metals react with the acids or dilute acids to produce salt and hydrogen gas. You must know that some of the metals react with dilute acids to produce salt and hydrogen gas. Remember, the dilute acids we are going to use are net sulfuric acid, dilute sulfuric acid, and dilute hydrochloric acid. Remember, we are not going to use nitric acid to react with the metals, dilute nitric acid. Why? Because nitric acid is a strong oxidizing agent and therefore oxidizes the hydrogen gas produced to water. So we are not going to use that. But bear in mind that when dilute acids react with metals, the end product is always salt and hydrogen gas. So this is one way of preparing salt, as well as another way of preparing what hydrogen gas in the laboratory. So now let's go and write this in B before we go into the deeper concept of this subtopic. Let's say metals react with dilute acids. Dilute acids to produce salt and hydrogen gas. To produce salt and hydrogen gas. Look at that. Salt and hydrogen gas. So when dilute acids are added to zinc, magnesium, aluminum, and iron, purples of gases are evolved. Purples of gases are evolved. So the production of purples of a gas in chemistry is referred to as effervescence. Look at that point. Be very keen. Look at that point. You are told when dilute acids are added to either zinc, magnesium, aluminum, or iron, purples of a gas are evolved. Purples of a gas are evolved. So the production of purples of a gas in chemistry is referred to as effervescence. Is referred to as what? Effervescence. The production, look here. The production of purples of a gas is referred to as effervescence. Effervescence. So this is S, remember. So effervescence means what? Purples. And that's why we said when metals react with dilute acids, the end product is what? Salt and hydrogen gas. So the liberation or the production of hydrogen gas results effervescence, which is what? Purples. Don't forget that. So now if I take now zinc, let me take zinc. Let us say zinc plus hydrochloric acid is going to give us zinc chloride plus hydrogen gas. Zinc chloride plus hydrogen gas. You see? So we know that zinc is a metal. So for those of you who are in Form 2 and Form 3, we know that zinc is a metal. So this is that. Plus hydrochloric acid, HCl, which is aqueous, is going to give us what? Zinc chloride plus hydrogen gas. Zinc chloride is salt, remember, so we're going to give what? The symbol will be solid. So we'll have zinc plus hydrochloric acid, zinc chloride plus hydrogen gas. So zinc chloride is a salt and hydrogen gas is the gas liberated here or produced. Now the confirmatory test of hydrogen gas is that hydrogen gas burns in air with a bobson. Okay? It burns in air with a bobson, and that is the confirmatory test of hydrogen gas. You see now? Or when a panning split is float on top of a gas cell containing the hydrogen gas, the gas burns with a pop sound, and that is the confirmatory test of what? Of hydrogen gas, for your information. Hydrogen gas, for your information. Then, there are some metals that cannot react totally with dilute acids. Like now, copper cannot react totally with either dilute hydrochloric acid or dilute sulfuric acid. Know that, please bear in mind that copper does not react either with dilute hydrochloric acid or dilute sulfuric acid. The other thing we are going to learn is group 1 elements and calcium reacts explosively with the dilute acids, and therefore we are not going to attempt their reactions in the laboratory. Just understand, the reaction between sodium, potassium, calcium with dilute acids is very explosive and therefore should not be attempted in the laboratory. Don't forget that. We said during the preparation of hydrogen, we said that we are going to use what? Copper tannings. Don't forget that. Copper tannings, because it reacts moderately with the dilute acids to give us the hydrogen gas required. Okay? The reaction between calcium and dilute sulfuric acids slows down and eventually stops. You can be asked in the examination room, explain why the reaction between dilute sulfuric acid and calcium metal slows down and stops eventually. So this is the reason, yeah. This is the reason as to why the reaction slows down and eventually stops. When dilute sulfuric acid react with calcium metal, we will have what? Calcium sulfate plus hydrogen gas. The calcium sulfate formed is insoluble and forms insoluble coating on top of the metal that prevents further reaction taking place between the metal and the acid. So in the examination, you're going to say, due to the formation of insoluble calcium sulfate, which prevent further reaction between the acid and the metal. In simple language. If you are told, explain why the reaction between dilute sulfuric acid and calcium slows down and eventually stops. So this is what you're going to say. You're going to say, due to the formation of insoluble calcium sulfate, which prevents further reaction taking place between the metal and the acid. Just understand. Okay? The other information here is, we cannot react nitric acid even when it's diluted with the metals, simply because nitric acid is a strong oxidizing agent and therefore oxidizes hydrogen to water. So we will not reach our target, we will not get hydrogen gas. Just understand that. The other thing we are going to discuss about is the reaction between dilute acids. Just understand this point. With the lead metal. The reaction between dilute acids and lead metal is slow. It is slow and eventually stops due to the formation of insoluble lead chloride and lead sulfate. Because when lead react with the dilute sulfuric acid, the end product will be what? Lead sulfate plus hydrogen gas. So that lead sulfate is insoluble. It therefore forms a coating on top of the metal, which prevents further reaction taking place between the metal and the acid. Also bear that one in mind, guys. Then when we react lead metal with dilute hydrochloric acid, the end product will be what? The lead chloride plus hydrogen gas. The lead chloride formed is solid and therefore forms a coating on top of the metal, which prevents further reaction taking place between the acid and the metal. Don't forget that. Please don't forget that. when I talk about the reaction between sodium with with dilute acid, it is very explosive because it's in group 1. Don't forget that also. Group 1 and calcium reacts explosively with dilute acids and therefore should not be attempted in the laboratory. Don't forget that, please. Okay? Don't forget that. And bear in mind that when dilute acids react with metals, the likes of iron, aluminium, magnesium, okay, or zinc, the end product is metal, salt. Sorry, the end product is salt and hydrogen gas. So this is one way of preparing salt, as well as another way of preparing hydrogen gas in the laboratory for your information. Okay, I think you don't have any question maybe, because these are the concepts of chemistry that can be asked during a national exam or any other exam, because we said dilute acids generally act with metals to produce salt and hydrogen gas. Bear that in mind, please. And in Form 1, a student must know what's reacting and what will be the product. So if I write zinc plus hydrochloric acid, remember metal is reacting with what? With acid. So the end product is what? Salt and hydrogen gas. Please know that. It's very, very important for you to know all word equations in Form 1. Then the moment you reach Form 2, you will be learning chemical equation and how to balance it, as well as stating the state symbol of that particular element or whatsoever. So otherwise, have a nice day. I think this was short and brief and to the point. Make sure you also go through and read. And bear in mind that when metals react with acid, the end product is what? When metals react with dilute acid, the end product is always salt and hydrogen gas. So let me add for you some examples, more examples here. More examples. Let's write this one. So when you say now, let us say calcium plus hydrochloric acid calcium plus dilute hydrochloric acid, it will give us what? Calcium chloride plus hydrogen gas. So if you're in Form 2, you can say like this: calcium, which is solid, plus HCl, which is aqueous, is going to give us what? Calcium chloride, which is solid. Don't forget, calcium chloride is written like this: C capital A Cl2, which is solid, plus hydrogen gas. See, the reason as why we have 2 here, we are going to explain in Form 2, inshallah God willing. Don't forget that. Okay? Because in Form 2 we said calcium has got a valence of 2, while chloride is negative, and so they will interchange position. I will not talk about this one. I will be talking about this when we will be discussing about the concept of Form 2 chemistry, inshallah God willing. Then otherwise, have a nice day. I wish you the best. Make sure you subscribe and share this concept with your brothers and sisters who are suffering at home level and is surrounded by COVID-19. Okay? I wish you the best.